there, geometry team. Time to go through our Unit 6 review for congruent triangles. Starting with problem number 1, we are given that E is the midpoint of segment AC and angle B is congruent to angle D. So let's go ahead and mark that on our picture so we know what information we have. If E is a midpoint, then we know that of AC, then we know that this side and this side have to be congruent because midpoints divide a segment into two congruent pieces. We're also given that angle B is congruent to angle D. Now, looking at those things, what else can we say about this picture? Well, let's see. We can probably figure out that this angle here is congruent to this angle here because those are vertical angles on either side of point E. So we don't have to set up the proof, but instead we can know that these triangles are congruent because when you focus just on this one, I have an angle and an angle that are congruent to each other. And then I have a side that is not in between them. So I know that the triangles are congruent by angle, angle, side. But I have to say which triangle is congruent to which one, and it's very important to list your vertices in the order that corresponds to this other triangle. So if I go from A to B to E, I go from a blank angle to this double marked angle to the center. So over here I should start with angle C because it is blank just like angle A was, then go down to angle D and then into E. So I'm going to be going to triangle C, D, E. Very important that you list them in order as they correspond to the other points. Problem number 2, we're going to do the same thing. Given that I have segment BD is perpendicular to segment AD, you're going to come here and go, okay, I know that AD is perpendicular to BD. Well, that tells us that these make right angles, and if we were writing the proof, we would make a step saying that. But here, we can just label it in the picture. We're also given that segment BD is the bisector of angle ABC. So segment BD here is bisecting this big angle. And anytime you hear bisector, you're going to get excited because you know that something is divided into two congruent pieces. And we want congruent pieces because we're trying to prove stuff congruent. So I can know that this angle is congruent to this angle. Now, in order to prove any triangle is congruent, I need 3 pieces. So I need to look for something else in this picture that is congruent on both triangles. And these two triangles share this segment down the middle. So I can say that it is congruent to itself. So now, looking at how these are arranged, I've got these 2 right angles will be congruent to each other. These 2 angles are congruent from the bisector, and this side is congruent to itself. So I know that these 2 triangles are congruent because of angle, side, angle. And now, to name the congruency, I'm going to say that triangle ABD is congruent to some other triangle, and the angle that's going to correspond to A is going to be C. Then I go up to my marked angle at B, so I will come up here, and it's also at marked angle B. And then I go down to point D, that's the same for this other guy. So it's triangle CBD is congruent to triangle ABD. In this last one now, state the congruence needed to prove that triangle DEF is congruent to triangle MNO. Okay. Well, we're going to have 2 different scenarios here with the same set of pictures, and so I'm going to use different colors for each one. So this one I'm going to do with green. Okay? So in this one, I'm given that DE is congruent to MN. So that's going to be this guy is congruent to this one. And then angle N is congruent to angle D. Okay? Now if I wanted to use side angle side, I've got this side and this angle. So the side I would need to do side angle side would be this one over here, which would be DF being congruent to MO. So I'm going to put that DF would need to be congruent to MO in order for side angle side to hold true. Now on this problem, if I were given that FE is congruent to ON, I would be given this purple stuff. Now we're ignoring the green stuff because that was for this other problem. So in this problem, I'm given that these two are congruent. So I'm focusing on the purple now. And that angle F is congruent to angle O. And if I wanted to use angle-angle-side congruence, I would need another angle congruent, but I wouldn't want angle E and angle M to be congruent because that would give me angle-side-angle. So in order to have angle-angle-side congruence, I would need angle D to be congruent to angle M. So I'm going to put that I would need angle D to be congruent to angle M in order to have angle-angle-side congruence. All right, and moving on, problem 4. Determine if these triangles are congruent and then explain your answer. That would be just to say side, 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 angle, how you know they're congruent. So for this one, I have an angle and a side and an angle congruent here. And they're even arranged in angle, side, angle. Now over here, I've got an angle marked congruent to the first one, and I've got an angle marked congruent to the second one, but the side that's marked congruent is not in between like it is in the first triangle. This triangle shows angle-angle-side arrangement. Well, that doesn't work. They have to be arranged in corresponding order. And so since these are arranged differently, these are not congruent. For problem B, I'm given that I've got a segment congruent to a segment, and another one congruent to another, and then just looking at the picture, I can see that this middle segment is congruent to itself. So I can say that yes, these triangles are congruent because they follow side, side, side congruence. For problem C, I can tell that I have a segment congruent to a segment, and then another set. So far I have segment and segment. And then for a third thing, I could say that these two are congruent because they're vertical angles, but that angle is not in between the two sides that I had. Instead, it's, if you follow through, I've got side and angle, and this is one of the congruence theorems that I could not use to prove triangles congruent. So no, I cannot determine if these are congruent. They might be, but we don't have enough information based on what is shown here. Problem D now. I have an angle congruent to an angle, I have another angle congruent to an angle, and then I have two right angles, and we know that all right angles are congruent, but I don't have any sides marked congruent, and so I have angle, angle, angle here, which means that no, I cannot say that these triangles are congruent because I do not have enough information. Angle, angle, angle tells me they might be similar, but they could be smaller or bigger. I don't know if they're exactly congruent. Problem E. I have an angle congruent to an angle. I have the side coming off of it congruent, and then the angle at the other end congruent. That is angle, side, angle congruence. So yes, I can say that these triangles are congruent. On problem F, I have an angle congruent to an angle, another one congruent, and then a side. And you might want to immediately say, oh, I have angle, angle, side, but let's double check to make sure that they're in order. By itself, I have the double marked congruent to the double marked. Then I move across to the single marked side, and then connected to the single marked one is my congruent side, congruent segment. So I have angle, angle, side here. So indeed, yes, I can say that the triangles are congruent. You aren't a bit suspicious here because you've seen where I've been tricky, and so you always want to double check that you've got everything in the right orders. They could be mirror imaged, but they need to make sure that everything corresponds, unlike this stinker up here. Number 5, tell whether you can determine whether mystery triangle JRM is congruent to triangle XYZ. I'm going to draw the picture for each one of these because pictures are always helpful in geometry. So I'm going to have a triangle JRM. I have no idea what it looks like, so I'm just going to randomly make JRM. and then I'm going to randomly make an X, Y, Z. But make sure you put everything in corresponding positions. So J will correspond with X, R will correspond with Y, and M will correspond with Z. Now I can go through and start seeing if I can say they're congruent. So I have JN is congruent to XZ. That would be this side. I have angle M congruent to angle Z. And then I have angle R is congruent to angle Y. And then I'm going to look at my picture and see if that actually works. So I have a double marked angle, a single marked angle, and then a side sticking off the end that is not in between the two. That is angle-angle side congruency, so yes, I can tell that those are supposed to be congruent. This is basically the same stuff as what we did at the top of the page, but in this situation, you have to draw and write everything based on what you read instead of it just being handed to you. Problem B now. I have, again, the same two triangles, and I have J, R, N, and X, Y, Z. Okay, in this situation, I'm going to have JN is congruent to XZ, just like before. This time I have JR is congruent to XY, and then angle J is congruent to angle X. So are these congruent? Well, I have side, angle, and side. And side, angle, side is one of my postulates that says I can be congruent. So yes, these are congruent triangles. Remember, don't trust the picture. Trust what we have here. I'm just sketching stuff. For my last one now, I'm going to have my same triangles being just as ugly as before. And I'm going to say, okay, I got angle J is congruent to angle X. Angle N is congruent to angle Z, and then angle R is congruent to angle Y. Well, I have angle, angle, angle here. I have three sets of angles, but I have no sides. So in this case, once again, I cannot say that those are congruent because angle, angle, angle is not enough information to determine triangles are congruent. Problem number 6 now. Now we get to do proofs. Woo-hoo! So in any proof, you're going to start by marking and paying attention to what you are given. So I'm given that segment AB is congruent to segment CB. So here's AB, and it's congruent to CB. And then I'm given that D is the midpoint of AC. So I'm just going to mark that point for now, and I'm going to start writing my proof. And I'm going to tell myself what I was given, because this is always the first step, just to make sure you really understand what you were given, is to write it down and mark it. So then I have that D is the midpoint, and I'm going to abbreviate because that's the thing I do. And so now I have those two pieces of information. I'm trying to prove that this triangle on the left, ABD, is congruent to CBD. So I'm trying to prove that these two guys are congruent. It's always important to know what you're trying to get done. So if I'm proving triangles, I'm going to need 3 parts that are proven congruent. I've already been given one. I've been given a side is congruent. And so then I'm going to start looking for more sides or some angles that are congruent until I get 3 pieces determined to be congruent. So starting off, I'm going to look back at my givens, and I'm going to see that D is the midpoint of AC. Well, midpoints tell me that I have congruent parts, and so I can use the D as the midpoint of AC to say that this piece, AD, is congruent to this piece, DC. So that will be my next step in my proof. AD is congruent to DC. And remember to mark them as segments when we're talking congruent. The reason I know that is because midpoints divide congruent segments. So I'm going to put that as the definition of a midpoint. And that is a second set of sides for my triangle to be congruent. So I'm only one step away from getting this done. So now that I've used up both of my givens, I'm going to start focusing on here and see, is there anything else I can tell from the picture? I see that these two triangles share a side, and so I can say it's congruent to itself. DB is congruent to DB because anything is congruent to itself by the reflexive property. And that gives me a third side congruent in my triangles, and so that gives me enough information to say they're congruent by side, side, side. And so I'm going to be ready to put this into my proof and go, all right, triangle ABD is congruent to triangle CBD by side, side, side congruence. Moving on toward number 7 now. Same song, second verse. I need to complete a proof. This one's a little more complicated, and so let's see if we can figure out what it wants us to do. We're trying to prove that a segment YZ is congruent to WZ. So I'm just trying to prove these two guys right here. I'm going to highlight them with a color, but I'm not going to mark them congruent because I don't know they're congruent yet. That's the whole point. I'm trying to prove it. So let's see what we are given now. I'm given that segment YX is congruent to segment WX. And I'm given that, pick a different color here, segment ZX, that's this guy down the middle, bisects angle YXW. So it bisects this guy right here. Okay? So let's go ahead and set up our proof and say, okay, I'm given, I started to write given on the left. That's so silly, Mrs. Cerna. Let's fix that here. Make it nice and pretty. Okay, so I'm given that YX is congruent to WX, and I'm given that segment ZX bisects angle YXW. Okay. Well, if I'm wanting to prove these blue segments congruent, they need to be in congruent triangles. And so it would probably help if I could figure out which triangles I'm using. There's a lot of triangles in this picture. But see how I have these two pieces here, and I'm probably going to use this set of angles. So I'm going to focus on this triangle on the left and this triangle on the right. Those will be the triangles I prove congruent, because if I can prove them congruent using these pieces up here, then I can say that these sides are congruent. Okay? And I've already been given one piece of that. I have been given the first side right there. Now focusing on my other given, that ZX bisects, that's going to tell me that I have this angle and this angle congruent because I bisected this big angle YXW. If it's bisected, these two parts are congruent. So I can say that angle YXZ is congruent to angle WXZ because of the definition of an angle bisector. It cuts an angle into two congruent pieces. And that gives me a second set of angles in my two triangles I'm attacking. So now I have an angle. Now I need a third piece in this big triangle congruent to this one. Well, they share this segment down the middle. So I can say that XZ is congruent to XZ by the reflexive property. And that is another side on my set of triangles. So I have a side and a side congruent, and I have an angle. That's three parts, but let's make sure they're in the good order. I have side, and then an angle on the end, and then immediately come to the other side. So this angle is being sandwiched in between these two sides. That is side angle side, and that is an acceptable thing to do. So I can go ahead and say now that this left triangle is congruent to the right by side angle side. But we need to make sure to name them in the proper order. It doesn't matter how you name the first one as long as you name the second one corresponding. So just because it's alphabetical, I'm going to go with XYZ is my triangle. Triangle XYZ. And I'm going to say it's congruent to the triangle on the right. But I'm going to have to start with its corresponding parts. So X, and then W, and then Z. Now I know those triangles are congruent, but wait, there's more. I'm not done because I still have to prove these two segments are congruent. But I have a triangle congruent to a triangle, and I've learned that corresponding parts of congruent triangles are congruent. So if these two triangles are congruent, all their parts are congruent, which means that this part right here has to be congruent to this part right here. So I can say that segment YZ is congruent to WZ because they are corresponding parts of congruent triangles. And so that means CPCTC is going to be our reason here. Problem number 8. I'm trying to prove the triangle ABE, this guy on the left, is congruent to CDE on the right. Cool, triangles. I need 3 parts. Let's look at our givens now. I am given that BD is perpendicular to DC. So BD is perpendicular to DC. So those guys are perpendicular. And I can say then that that's going to make a right angle, but I can't write it yet because I'm going to finish writing my givens. I also know that BD is perpendicular to AB. So I'm perpendicular at this end. That's another given. And I'm given that AB is congruent to CD. So segment AB is congruent to segment DC. That's given, so I can actually mark that's congruent. Okay? So now I have a set of sides congruent in my triangles. Now I'm going to look for angles. Well, I knew that these guys were perpendicular, so I know that this is a right angle. So I can say that angle D is a right angle. And in the same light, I can say that angle B is a right angle. And that's for both of those, that's because perpendicular lines form right angles. Well, now that I know that they're right angles, I can say that angle D is congruent to angle B because we learned a couple of units ago that all right angles are congruent. So now I can say that angle B is congruent to angle D because they are right angles. So that's an angle now that both of those have. So I still need one more part, but I've pretty much used up everything I was given. So now I'm going to start looking for other stuff that I'm not told. Well, anytime you see this crisscross shape here, get real excited because that tells you you've got some vertical angles. And vertical angles are always congruent. So I can say that angle AEB is going to be congruent, AEB is going to be congruent to CED because they are vertical angles. And that gives me a second angle congruent in my triangles. So now I've got a side and an angle and an angle. Let's make sure how they're arranged. Do I have angle, side, angle, or do I have angle, angle, side? Well, if I start in the middle, I have an angle, and then I get to my second angle without crossing a side, and that side, instead of being in between these two guys, it's sticking out the end. So I definitely have angle, angle, side congruency here, and I can go ahead and then say that I have proven triangle ABE is congruent to triangle CDE. And you are done. Moving along, problem number 9. We've got numbers and all sorts of stuff going on in here. The numbers are going to be helpful because they're going to let us name angles without having to keep straight all the different letters. So that's always really useful in a diagram when they have named angles separately from all the letters. So let's focus on our givens and see what we've got. We are given that AB is parallel to DC. So AB is parallel to DC. We are also given that BC is parallel to AD. So that means this guy is going to be congruent to this one. And I need to prove that triangle ABC is congruent to triangle CDA. And I don't have a single congruent thing given to me. So it's all up to us to remember properties from before that can give us information. looking at my givens, I have parallels. And if you think back to previous units, we were given, or we were told, that when you have parallel lines that are cut across, we have alternate interior angles congruent. So CB is parallel to AD. This is going to cut across it, so angle 3 is going to be an interior angle, and angle 1 is going to be an interior angle. So I can say that angle 3 is congruent to angle 1 because alternate interior angles are congruent when you have parallel lines. Then I can also go in and say, well, wait a minute, if these guys are parallel, that same transversal now makes angle 4 an alternate interior with angle 2, because now I'm going this way over here and up to here. Whenever you have that Z shape is when you have the alternate interior angles. So I'm going to have angle 4 is congruent to angle 2, also by alternate interior angles being congruent when you have parallel lines. Well, that's well and good. I have an angle on each triangle and another angle on each triangle, but I need a third thing. And I can't look for another angle because I'm not allowed to use angle, angle, angle in a proof. So now I'm going to look for congruent sides. And oh, happy day, the triangles are touching, so they share a side right here. And so I can say that segment CA is congruent to segment CA by the reflexive property. And that gives me a side now congruent. So I'm ready then to go ahead and say that triangle ABC is congruent to triangle CDA. And look here, I have a set of angles, another set of angles, and then the side that connects them, and so that's going to be angle, side, angle congruence. Moving on, you're almost done, y'all. You only got 2 more. Number 10, I am given that angle B is congruent to angle E. Here's angle B, here's angle E, and I'm going to put that in my proof. Angle B is congruent to angle E. And then I'm also given that C is the midpoint of BE. And so C here is the midpoint. Now, it's going through 2 lines, so really be sure that you know that it's the midpoint on BE. I don't know how long AD is. These 2 sides might be congruent, but they might be different lengths. I don't know. The only midpoint I know for sure is that I'm in the middle of BE. So I can go through now and say midpoints are exciting. They tell me congruent parts. I can say that I have BC is congruent to CE since I'm bisecting that one. So I can say that BC is congruent to CE because of the definition of a midpoint. And that gives me a side congruent on each of my triangles. Well, I already had an angle congruent, so oh dear, I'm not proving triangles congruent. I'm proving pieces congruent. I've got to prove that this angle is congruent to this angle. Oh, but remember, I'm always trying to prove triangles congruent so that I can prove parts congruent. So if I could just find something else that makes these triangles congruent, then I can say, well, then their parts have to be congruent by CPCTC. So I'm going to look for something else and continue on trying to make these triangles congruent. And since I have this crisscross shape in the middle, I can say that this left angle is congruent to this right angle. This is angle BCA is congruent to angle DCE because they are vertical angles. And that gives me an angle now. Now looking in here, I have an angle and the side in between, so I definitely have angle-side angle congruency, and I want to say the triangles are congruent, but remember to name them in corresponding order. So if I name this guy on the left ABC, because I like things alphabetical, then I need to make sure to use the corresponding pieces over here. A is my unmarked angle that I'm going to say is congruent to this other unmarked angle, D. Then I'm going to B next. B is my single marked angle that I already said was congruent to E, so E is definitely next. And then C will be last in both of them. This order does matter, so make sure you pay attention. Well, I still haven't proven what I want to prove. I have to now take that step to say that angle A is congruent to angle D, because that's what you're trying to prove. How did I know that? Well, I just told myself that these triangles are congruent. So then I know that their corresponding parts are congruent by CPCTC. Corresponding parts of congruent triangles are congruent. Then your last one. This is another one where we are proving parts, but in order to prove those parts, since I have triangles, I bet you anything, I'm going to have to prove the triangle's congruent so that then I can say that the parts are congruent. So let's begin. I'm given that BD is perpendicular to AC. So BD here is perpendicular to AC. And then I'm also given that segment AB is congruent to segment BC. And so far I have a side congruent. And that's all I have listed as congruent. I'm going to start looking for other parts being congruent. Focusing on my givens, I'm given that there are two perpendicular pieces. And I know, because I've paid attention in geometry class, that perpendicular lines form right angles. So I can say that angle ADB and angle CDB are both right angles because of the definition of perpendicular. Perpendicular tells me that I make right angles. Now that I have two right angles, I can say that angle ADB is congruent to angle CDB because all right angles are congruent. So now these are marked as being congruent, and I have a set of angles that are congruent. I need a third part, though, in order to say that triangles are congruent. So I start looking through it, and I'm really tempted to use this one being congruent. But if I marked this congruent and put it in my proof, I would have a side and a side congruent, but then I would have an angle that's not in between them. And so that would give me side-side angle, and that is not one of our appropriate things we can use. But we do have right angles, which means these are right triangles. And I do know that in right triangles, there's a special version of SSA that's called hypotenuse leg or hypotenuse leg right. And that one lets me say they're congruent. So let's see. Since I have a right angle, the side opposite, here's my hypotenuse, and I have a leg, and I have a right angle. So this would help me to be able to prove they're congruent. So yeah, I'll go ahead and go with this and say yes, BD is congruent to BD by the reflexive property, because this is going to actually be helpful now. So now I can go ahead and say that triangle, let's make sure to make it corresponding, ADB and then CDB. So I'll do ADB is congruent to triangle CDB. And we use hypotenuse leg right for that. But that's not what I was trying to prove. I'm trying to get these pieces. So now I'm going to look and see, okay, here's AD, here's DC. They are corresponding parts of these congruent triangles, so I can say that AD is congruent to CD by CPCTC. All right, team, there you go. If you can do these kinds of things, if you can figure out what right angles are helpful for, what reflexive property can do for you, what vertical angles do, all your different setups of congruency, you're going to be okay for this test. So good luck and have a great day.